Okay, let's talk about some other special segments. A median extends from the vertex of a triangle to the, and if you look at the picture, it's the midpoint of the opposite side. Triangle has three sides, therefore it has three medians. You look at the picture, it starts up here at point L, that's the vertex, goes down to the midpoint O. I know O is a midpoint because of the tick marks. All three medians intersect. That point is called the centroid. So if you look at my picture, I've got medians PZ, CX, AY. They all meet at point P. Point P is called the centroid. Now, what's special about the centroid is that it splits the entire BZ into two pieces. You got piece BP and you got piece PZ. Well, PZ is 1/3 of the entire line. P to B is 2/3 of the entire line. So your line gets split up into three parts, where PB is going to be 2/3 and P to Z is going to be 1/3. The segment we have is called an altitude. Altitude extends from the vertex of a triangle to the opposite side at A. And if you look at the picture, that's a 90-degree angle. So it has to be perpendicular. The triangle has three sides. Therefore, it has three altitudes. What's special about an altitude is an altitude can be inside, outside, or on a triangle. So the pictures down here I kind of showed you. Here's some altitudes. On an acute triangle, the altitudes are inside. But on a right triangle, the altitudes, you have one inside and the other two are on the triangle. That would be AE and EB. Those two are altitudes of a right triangle. And when you have an obtuse triangle, one of the altitudes is inside the triangle. The other two, AD and EB, are outside the triangle. So you got to figure out what type of triangle you have, and it's going to depend where the altitudes go. Okay, the point where all three altitudes intersect is called the orthocenter. So if you look at my pictures, the orthocenter could be inside the triangle, on the triangle, or outside the triangle, depending on what type of triangle you have. If a triangle is isosceles, so here in this case, isosceles, AB and BC are equal, what happens is this altitude, because it goes from the vertex A down at a 90-degree angle, so AD is your altitude. But what is it doing to side BC? It's actually bisecting side BC, creating BD and DC being equal to each other. So if you have a nice altitude of an isosceles triangle, that is also called a median. It's also called a perpendicular bisector. Bless you. And this thing is also angle bisector. So if you have an isosceles or equal out of a triangle, altitude could be a median, a perpendicular bisector, or an angle bisector, meaning that these two angles up here are going to be equal to each other.